Hey guys, so today we're going to be working on finding the distance between two parallel lines. Remember, we have done this the last few days, so this is just another way to look at it and work in Desmos.com. So what we want to do, we want to go to Desmos.com, okay, then we're going to open up our graphing calculator. All right, we want to find the distance between these two lines right here. So in this example, if we had this on a graph, our lines would look something like this. So 2x plus 4 and then 2x minus 2. Okay, we want to find the distance between these two red lines. Remember, going over our information last week, we need to find the perpendicular line that intersects with these two parallels. Okay, so what we have to do, since this is a perpendicular line, we need to first find a perpendicular slope. Okay, remember, perpendicular slopes are opposite reciprocal. And then what that means, remember, is change your sign and flip your fraction. Okay, so where do I find the slope for my opposite reciprocal? All right, you're just going to look at the slope that they already give you. So in this case, we have 2 as our slope, positive 2, but in order to make it perpendicular, we need to make it the opposite, which is negative, and then the reciprocal, okay, remember 2 is just 2 over 1 as a fraction. So the reciprocal of that, we flip it and it becomes 1 over 2. So now we know that our slope has to be m equals negative 1 over 2. So where this graphing part comes in, I'm going to take each individual graph and put them into my graphing calculator. So we have y equals 2x plus 4, okay, and then y equals 2x minus 2. Okay, again, so this looks somewhat similar to this little graph that I kind of sketched out. We wanted a perpendicular line to find our distance, okay, and we said that our line's slope is negative 1/2 x, okay. Does that look somewhat like mine? Yeah, because we have two parallel lines and a perpendicular that is crossing. Okay, remember, like we need to find the distance, okay, this segment in between our perpendiculars is what we're measuring. So this green part right here, okay, we're going to use these points given. Okay, so I'm going to jot these down. We have negative 1.6 and 0.8, and then our other point where they intersect is 0.8 and negative 0.4. Okay, so since we need to find the distance between these 2 points, we want to use our distance formula. Okay, so that is d equals the square root of the difference in our x's squared plus the difference in our y's squared. Okay, so in order to find this distance right here, we need to plug in our x's and y's right here. All right, this is where our second tab comes in handy, right? So we're going to be at Desmos in the scientific calculator. Okay, so you can either go to desmos.com and then select it, or just type in desmos.com/scientific. Okay, if you are to write out your distance formula just how it's written, you can type it into your calculator. So I'm going to do that first. So I'm going to label my coordinates as 1s and 2s. All right, then I'm going to just plug them into my equation. So we have 0.8 minus a negative 1.6 squared, and then negative 0.4 minus 0.8. Okay, so before I get started, remember, a double negative turns into a positive, so I want to change that before I type it into my calculator. Okay, and then next we just go in here and type in exactly how it's written. So we have the square root of 0.8 plus 1.6, close your parentheses and square it, and then we add negative 0.4 minus 0.8. Close your parentheses and square that again. So this gives us an answer of 2.68328. Okay, and it's actually bigger, but for the purposes of this assignment, we only want to round to the nearest thousandths. Okay, so 3 decimal places, right? Remember, if this number is lower than 5, you just keep your thousandth decimal where it's at. So our distance between our 2 parallel lines is going to be 2.683. All right? We'll do one more example together, and then you should be good to go. All right? So going back to my graphing calculator, okay, I'm going to clear out my equations, and then we're going to move forward to our second example. Okay? So here we have y equals 2/3 x plus 2, and y equals 2/3 x minus 3. So what we know is if this was graphed, it would look something like this. So plus 2, and then r minus 3 would be something like that. We want to find, again, the distance between these parallel lines, okay? And our distance has to be perpendicular, okay? So first step, we need to find the slope of our perpendicular line. Okay, so we look at the slope given here, 2/3. Remember, perpendicular has to be opposite reciprocal. This is going to make our new slope -3/2. Okay, so now we have our slope, and then our previous lines, we type them into our graphing calculator. So 2/3 x plus 2, 2/3 x minus 3, right? And then last, we have our perpendicular slope. It's -3/2x. Okay, so my little sketch looks very similar to what they give me here. We need to find the distance, so this in between section, we have our parallel lines, we want all of this distance between it. So we write down our points. We have -0, 923, 1, 385, and then our second end point is 2077, and that's a -2. Okay, so again, we're looking for the distance, therefore we need our distance formula. All right, now since it's an equation, I go back to my scientific calculator. I want to plug in my x and y values, so I'm going to label them 1s and 2s. We have x2, which is 1385, minus a negative x1 value. Square that. And then our y2 is subtracting this, 85 squared. Okay. Before I start typing it in, remember I have a double negative right here. This becomes a plus sign. And then last step, we just type it into our calculator. You can solve it by hand. If you want to do that, go for it. If not, you can always double check here. So we type it in as it's written, plus, and square it. That, and that gives us an answer of 4.1608. Again, remember we need it in the thousandths, so this leaves us with 4.161. and that is your distance between your two parallel lines right here. Let me know if you guys have any questions. Good luck on your assignment.